Hey everyone, and welcome to the channel. Today, we're diving into a spacey question that might have you feeling a bit weightless. Is floating in space the same as falling under gravity? Strap in, because we are about to blast off into the world of physics and unravel this cosmic mystery. First things first, let's clear up a common misconception. There's no such thing as zero gravity in space. Even astronauts orbiting Earth experience gravity, though it's much weaker than what we feel on the ground. So, how do astronauts float? It all comes down to a concept called freefall. Imagine jumping out of an airplane. As you fall, you experience weightlessness. That's because you are accelerating towards Earth at the same rate as everything else around you. No pushing, no pulling, just the gentle pull of gravity. The same is also true for the International Space Station, which is a giant man-made satellite, constantly falling towards Earth. But here's the twist. It's also moving sideways, at a very high speed. This sideways motion cancels out the downward fall, creating a state of microgravity, which feels like weightlessness. As astronauts travel beyond Earth's atmosphere, they experience a feeling of weightlessness. The speed of their spacecraft moving forward in orbit cancels out the effects of the downward pull of Earth's gravity. This causes the astronauts to enter a state of free fall, which feels like floating to them. You may experience a similar feeling on a roller coaster. As you climb higher and higher on the track, you will feel your body being pushed back into your seat due to gravity. Once you reach the top and begin to descend, you may experience a moment of weightlessness, a feeling of floating, before your safety harness pulls you back down with the rest of the ride. So, both falling and floating in space involve experiencing no net force. That's why they feel the same to our bodies. But there are some subtle differences. For example, free fall on Earth involves air resistance, while in space, there's almost none. The only difference is that, in space you are falling around an object, instead of towards it. Imagine throwing a baseball horizontally. It will curve down and hit the ground, because of gravity. But if you throw it faster and faster, it will curve less and less, until it goes so fast that it curves around the Earth, instead of hitting it. That's what orbiting is. Falling around an object instead of towards it. Albert Einstein, the legendary physicist, saw the connection between free fall and weightlessness as a cornerstone of his theory of general relativity. He basically said that gravity isn't a force, but a curvature of space-time. So, when you are in free fall, you are not actually falling towards anything, you're just following the natural curvature of space-time. There's still so much to explore in this topic. We can delve into the effects of microgravity on the human body, the challenges of spacewalking, and even the mind-bending physics of black holes and their intense gravity. So, what do you think? Did this video clear up the confusion about floating and falling in space? Do you have any other space-related questions? Let us know in the comments below.